chemistry students, it's Mrs. Campbell. We're going to talk about the conservation of matter and how chemical compounds always have the same chemical formula. So first, conservation of matter. You've probably heard the law of conservation of matter before in a previous science class, but it just says that when there's a chemical reaction, we don't destroy any mass. So if I put 20 grams into a reaction, I get 20 grams out of that reaction. This was actually discovered by the French scientist Antoine Lavoisier. He's considered the father of modern chemistry. He made quite a bunch of contributions to chemistry, but unfortunately, he was a tax collector during the French Revolution, and he was guillotined. Quite disappointing, because I can imagine how many other things he might have discovered. Now, have you ever wondered, is water always water? The formula for water is H2O, right? 2 hydrogens and 1 oxygen. But is it always that? Well, actually, that's true. And that's called the law of definite proportions. And what the law of definite proportions says is that a chemical compound always has the same ratio of elements. So water always has 2 hydrogens and 1 oxygen. If it doesn't, then it's not water. So that's a good example of the law of definite proportions. Another example is sodium chloride. Sodium chloride is actually table salt. So what you put on your French fries. The formula for table salt is sodium chloride. And so it's always 1 sodium with 1 chlorine. If there's a different amount of sodiums or chlorines, then it's not sodium chloride. So that's the law of definite proportions. Now, there's also this law called the law of multiple proportions. And what that says is that we can have hydrogen and oxygen in different proportions, but then they're different compounds. So the law of multiple proportions is different compounds can have the same elements, so hydrogen and oxygen, for example, but they must have different ratios. So, for example, water, right? I just said water was 2 parts hydrogen and 1 part oxygen, so 2 hydrogens per oxygen, or H2O. But hydrogen peroxide, here's some hydrogen peroxide we use for cleaning wounds. Also, we use it for bleaching teeth. Is also made out of hydrogen and oxygen. But it has 2 hydrogens, just like water, but it also has 2 oxygens, so it's H2O2. But how do I know what I have? I have 2 little glass jars here, and one has oxygen, one has water, and one has hydrogen peroxide, but how do I know which is which? They don't smell any different. They don't look any different. But I don't want to drink the hydrogen peroxide. Well, we could actually... What if we could break them apart? What if we could break out the hydrogens from the oxygens, right? If we did that, then the hydrogen peroxide will have more hydrogen to oxygen ratio than my water. So we can do this by what's called percent by mass. So if we break apart our hydrogens from our oxygens, and we know how much mass we started with, then we can take a ratio of the mass of each of those elements and divide by the total mass of the compound. So percent by mass is a calculation we do where we take our total mass in grams of the element and we divide by the total mass in grams of the total compound. And then, of course, we need to multiply by 100. It's kind of like when you calculate your grade on a test, right? You take your total points, how many points you got on the test, right? That's the part, and divide by all the points, that's the whole, multiply by 100, and you get your percent on your test. Let's take a look at an example. Let's look at sugar. Yummy. If I start off with 20 grams of sugar and I break it into each of its elements, sugar is made out of carbon, hydrogen, and oxygen. What I would find is that I would get 8.44 grams out of the 20 grams of carbon, 1.3 grams of hydrogen, and 10.26 grams of oxygen, right? These, well, when we add these up, they should equal 20. Why should they equal 20? Well, remember, the law of conservation of mass says that mass can't be destroyed in a chemical reaction. So if I take 20 grams of sugar and I break it into elements, I better have all those elements add up to 20. Now, if I want to calculate percent by mass for each element, right, percent by mass, we're going to take the part, the mass of the element, and divide by the whole, the mass total. So for carbon, we're going to take our 8.44 grams and we're going to divide by 20 and then multiply by 100, and I get 42.2%. We can do the same thing with hydrogen, right? We take our part, the 1.3 grams of hydrogen, divide by the 20 grams total times 100, and you get 6.5%. And of course, we can do the same with the oxygen, 10.26 grams of oxygen divided by 20 grams of sugar, multiply by 100, and we'd find that oxygen is 51.3% by mass of sugar. Now, also these, because this is a percent and we're dividing each part by a whole, if these equal 20, then when we add these up, this better equal 100. So how do we work with these together? Remember, the law of multiple proportions said that you can have different compounds made out of the same elements, but they have to be in different proportions. And in fact, if we took two copper compounds that we found and we broke them into copper and chlorine, we would find that there are two different types. There's one in my compound 1 here where I have more percent copper by mass than chlorine, whereas in compound 2 I actually have less percent copper by mass than chlorine. And so that means that these compounds must have different numbers of coppers to chlorine. And in fact, if we set up a mass ratio and divided our mass of copper by the mass of chlorine, we would see, like if we did multiply this by 2, right, we'll get a number close to this, which means that compound number 1 must have twice as much copper as it does to chlorine. And in fact, if we then did some conversions to moles and we did some mole ratios, which we're going to learn about later this semester, we would find out that compound 1 is actually copper 2 chloride. It has 2 coppers to 1 chlorine, and compound 2 is copper 1 chloride. So different amounts of copper and chlorine combine to make different substances, and I can tell them apart by using percent by mass. See you in class.